Bismillahirrahmanirrahim. Welcome students. Today we will start new chapter kinematics. Kinematics is a branch of physics in which we discuss the motion of objects. Motion of objects such as car moving on a straight road, apple falling to the ground without taking into consideration the cause of their motion. In this unit, we will also be getting familiar with different terminologies like speed, velocity, distance, displacement, acceleration. But before that, we must be able to describe the state of motion and rest precisely. In physics, rest and motion are two different states of body. In today's lecture, we will learn about the two states and try to find out the difference between them. We will discuss the types of motion by using examples. So what is state of rest? When we look around us, we observe that many things do not appear to move. Thus, we consider them in state of rest. Or when object is not doing any work, it is in state of rest. In physics, however, we define the state of rest with respect to its surroundings. So the proper definition is if an object is not changing its position with respect to its surroundings, it is in state of rest. For example, bench in park is at rest with respect to its surroundings, as there is no change in its position. Similarly, books lying on the table are in state of rest, as the position is not changing. Fruits will remain in the basket in state of rest unless we change their position by picking them up. When the position of an object changes with time, we say that it is in motion. In physics, however, we define the state of motion as if an object is changing its position with respect to its surroundings, it is in state of motion. For example, birds flying in air are in state of motion as they are changing their position with respect to the stationary objects. For example, mountains. A fast-moving train is changing its position with respect to its surroundings. It is said to be in motion. Kids playing in park are also in motion as compared to the stationary objects around them, like trees. So, in short, rest and motion of an object are being observed with respect to its surroundings. So, what is the difference between rest and motion? First point, for rest, when the position of object does not change with time, it is in rest state. Second, the object does not move with respect to its surrounding. It is in rest state. For example, books lying on the table are at rest. Motion. When the motion of object changes with time, when the position of an object changes with time, we say it's in state of motion. Or the object moves with respect to its surroundings, it is in state of motion. For example, fast moving train. So why we say rest and motion are relative? What is meant by the term relative? Relative means that a body may seem to be at rest with respect to one object, but may appear to be in motion with respect to another object. Let's consider a simple example. If you see this interesting picture at the top right corner of the screen, this is you sitting on a chair watching this online video of physics. You are in state of rest and you are living on this green ball. This green ball is the planet Earth. So you are at rest with respect to the Earth. This is one object, Earth. You are at rest with this object Earth, but with respect to the Sun, you are in motion. Why? Because Earth revolves around the Sun, and since you are living on it, you are also revolving around the Sun. So Sun sees you in motion. So in short, you are at rest with respect to Earth, and you are also in motion with respect to the Sun. Let's see the second point. It is meaningless to discuss rest and motion without the observer. Yep, it is an observer, that is the person, and the surroundings, that are the objects, that decide whether a given object is in state of rest or motion. And there is no such thing as absolute rest or absolute motion. What is absolute? Absolute word means something that is fixed and non-variable. So absolute rest means that a body is stationary, motionless. And absolute motion means that the motion of body does not depend on anything external to moving object for its existence. For example, if you were born then and for whole life you would have been a newborn baby. So this is the problem with absolute rest, that it doesn't allow any change. And for absolute motion, if you start from your home and go to college on a bicycle and you keep on going forever and you still don't reach college, that is something impossible. How can an object be motionless forever? And how can an object remain in motion forever? Everything moves, even though they may appear to be at rest. See the picture? The passenger sitting is at rest with respect to the moving train, but it is also in motion at the same time with respect to the objects like trees, buildings, houses that are outside the train. Let's see another example. There are two passengers sitting in a moving train. The passengers are observing each other, and to them, they are in state of rest with respect to the moving train. But to the surroundings, that are the objects outside the train, they are in state of motion. Thus, we conclude that they are in state of rest and motion at the same time with respect to observer and surroundings. Different objects have different types of motion. For example, train moves straight along its track, a fan rotates around its axis, earth revolves around the sun. We classify different types of motion based on path followed by object. There are three basic types of motion: translatory motion, rotatory motion, vibratory motion. And translatory motion is further subdivided into linear, random, and circular motion. Let's see their definitions and learn them more through examples. In translatory motion, the body moves along the line without any rotation, and the line may be straight or curved. By line, I mean the path. The path can be straight or curved. In the first picture, the ball is following the straight path while rolling away. The apple falling from the tree is coming straight vertically down to the ground. All the cars are moving on a straight road, but the line, that is path of road, is curved. Translatory motion is further subdivided into linear motion, circular motion, and random motion. Linear motion is motion of a body in a straight line. For example, a car moving on a straight road, an apple falling straight on the ground. Important point to note is that the path is straight. Circular motion is a motion of object in circular path. For example, revolution of Earth around the sun, motion of toy train on its track, motion of cycle while taking a turn on road. All of these examples are of circular motion. Important point to note, path is curved. Random motion. The irregular or disordered motion of an object is called random motion. For example, the gas particles in a container, path followed by insect or butterfly. These are all irregular motions. Again, the important point to note is that in random motion, there is a zigzag path. Rotatory motion, when an object moves in such a way that every point of object moves about a fixed axis, then motion of an object is called rotatory motion. Or in simple words, spinning motion of a body about its axis is called rotatory motion. What is axis? Axis is an imaginary line around which a body rotates. See the first picture. The wheel is spinning from its center. It is a rotatory motion. Ceiling fan moves around its axis. This is an imaginary line passing through this point, and the blades of the fan, they are moving around this axis. The spinning top, the spinning top, the axis would be over here in the center like this, vertical, and this top is spinning around its axis, on its axis. The rotation of Earth on its axis. These are all the examples of rotatory motion. So what is the difference between circular and rotatory motion? Circular motion is the motion of an object in a circular path. This is the motion of an object in a circular path. And in rotatory motion, the body is actually spinning. It is moving round and round about its axis. In circular motion, the point about which a body goes round is outside the body. In rotatory motion, the line around which a body moves about is passing through the body itself. You can see in the picture, this is the Earth, this white line, vertical white line, a little bit tilted, is the axis. This is an imaginary line. You can't actually see it on the Earth. So this Earth is spinning on its axis. And this is the path. This is the circular path. This is the circular motion. So you see the difference now. Vibratory motion, to and fro motion of a body about its mean position. The condition is that a body has to move back and forth, but about its mean position. So what is mean position? Mean position is the starting position, the stationary position. For example, you go to a park and you see a swing. Nobody is sitting on it. It's stationary. That point is its mean position, the stationary position, the rest position. But once you sit on it, the swing will start moving back and forth. The motion continues, but this motion is about its mean position, that is the stationary position. So such a motion is called vibratory motion. Consider the second example. The motion of pendulum of a clock. This is pendulum. This yellow stick with a ball hanging. This is pendulum. So let's say if it was stationary, it was straight, vertical. When it starts moving, that straight position was the mean position. And when it started moving left and right, it was moving about its mean position. So this left-right motion of the pendulum about its mean position is called vibratory motion. Consider the third example. Suppose you tied a string with two ends of the wall. When you didn't touch it, it was stationary. That was the mean position, the starting position, the rest position. But once you plucked it, it started to move up and down, like in this picture, up and down, but about its mean position. So, this kind of example is also of vibratory motion. Quick point. Let's see you understood the types of motion or not. First, a ball moving vertically upward. What sort of motion is it? Since the ball is moving vertically upward, the path, there's a hint given. The path is straight. It is moving upward, straight path. It is a linear motion. A child moving down a slide. Slide can be straight or can be curved. So it is a translatory motion. Movement of football player in football ground. A player will move in a irregular pattern to reach to the goal. So that irregular movement in the football ground would be random motion. Flight of butterfly, random motion. An athlete running around a circular track, circular motion. The motion of wheel, already discussed in lecture, it is rotatory motion because it will be moving around its axis, along its axis. And vibratory motion, motion of a cradle. Lecture of today's summary, we discussed rest, that if a body is not changing its position with respect to its surroundings, and motion is when a body is changing its position with respect to its surroundings. Then we discussed the types of motion, translatory, rotatory, vibratory, and we discussed translatory motion further into three types as linear, random, and circular. I hope you got today's lecture. Home assignment is you have to revise the lecture. You have to do question 2.2 and 2.3. In 2.3 question, you have to attempt part 1, 2, and 5 in your copy. I'm sorry, I forgot to write 5. But you have to do 1, 2, and 5. Still, if you have any problem regarding the lecture, you can contact me on my WhatsApp number. See you in next lecture. Take care. Allah Hafiz.